Hello, students, and welcome to another exciting algebra lesson. For our Do Now, we have a prompt about being kind, and I'll ask you to respond attentively to that. We will review equations and solve a few more word problems using our algebra tools. So that's our Do Now and our objective. Our essential question is how can we recognize the important components of an algebraic word problem, and how can we use these elements to build a solution? And building the equation is usually where the real trouble is, and that's the hard part of solving. Solving is much easier than building the equation, I think, for many students. We're going to watch this video and complete word problems number 1 to 20. We have an exit ticket where I want you to think carefully about the steps to solving a word problem. We talked about those. And I want you to think about which of those steps is more difficult for you as you solve word problems. Our homework tonight is homework number 9, our word problems review. And I want you to remember to check PowerSchool and assignments and teams often. We want to make sure that you're caught up on everything, especially as we get close to the end of the marking period. Especially if you're a distance learner, did you show me your notes, class notes this week? And if you're an in-person learner, we need to see those in school on the days that you come to school. So please be sure to bring your notes every day, because that's how we learn algebra. We watch and we learn and we practice by writing the problems and doing them as we learn. So today's pumpkins. I'll make this a girl pumpkin with a little bow in her hair. And I'm sure these guys are all ready for trick-or-treating, but they're not too scary. So let's move on. This was our Do Now that we talked about how we can live kind. We have that acronym, Know Every Person Has Value and Deserves Kindness. K, I, invest in connecting or listening to others. N, notice others' perspectives and feelings. And D, demonstrate care, concern, and compassion through action. Our exit ticket today, we're asked to think again about what are the steps that we need to take to solve a word problem. And I want you to think about which one is most difficult for you, and that should be the one that you work on. So let's get started. It's a review day today, so we're going to review these equations and word problems. So in looking at this first word problem, the first thing I need to do is to distribute this -2 through that set of parentheses. And then I have a negative. Remember, the negative is really like an invisible -1, but the effect of that negative is simply to change the sign inside everything in parentheses. So let's get started. So -2 times 4 is -8x. And -2 times +3 is -6 minus x plus 7 equals 46. So we've got some combining like terms. We have -x minus x. That's minus 1x. So that's a -9x. And we have -6 plus 7, so that would be plus 1 equals 46. And this problem just got a lot easier. I'll subtract 1 from both sides for -9x equals 45. Divide both sides by -9, and x equals -5. In number 2, we've got a fraction. Couple of ways we can handle it. Really, what's happening is we're going to distribute -4/3 and multiply it times 12 and multiply it times 27. Remember, you can always make a sidebar. -4/3 times 12 over 1 equals negative times a positive, that would be -16. So we have -16k. Now let's do -4/3 times 27. So that would be -36. equals negative 57 minus 9k. Let's add 16k to both sides. We'll get our k's positive. So negative 36 equals negative 57 plus 7k. And let's add 57 to each side. And that will give us 21. A positive 21 equals 7k. And let's divide both sides by 7. And k equals 3. I see I forgot to box my answer over here. Number 3, we're going to multiply this negative 2 distributed into the parentheses, through those parentheses. And then we'll do the same with the 5. That's our first step. So we will have 23 minus 10a minus 18 equals 10a minus 55. So we can combine 23 minus 18, which will give us, we'll still have that negative 10a minus, or plus, plus 5 equals 10a minus 55. And I think the next thing we'll do is we will add 10a to both sides. Now we have 5 equals 20a minus 55, and now we'll add 55 to both sides of the equation, which will give us 60 equals 20a, and when we divide both sides by 20, our a equals 3. Okay, another fraction, that's fine. I'm not afraid of the fractions. So if we multiply 5 over 2 times 6, we will have 15w. If we multiply positive 5 over 2 times negative 16, we will have negative 40 equals 18w. And then this, when we distribute, simply changes the sign of everything in there. So negative 3w minus 40. Now we can combine like terms on the right, 18w minus 3w. So let's just copy the left side, 15w minus 40. 18 minus 3 is 15w minus 40, and I hope you see what's actually happening here. If we subtract 15w from each side, we end up with negative 40 equals negative 40, which means that there are an infinite number of solutions that will work for the value of w in this equation. So w, we can substitute an infinite number of values, and that equation will remain true. So the next 2 are proportions. The next 4 are proportions, 5, 6, 7, and 8. We use cross products. We multiply 10 times 6 and set it equal to 5 times the quantity of a minus 6. So we'll set up our problem. 10 times 6 equals 5 times the quantity of a minus 6. So that would be 60 equals 5a minus 30. And we'll add 30 to both sides. And we end up with 90 equals 5a. divide both sides by 5, and A equals 18. I hope you try these on your own before you watch me do them. You should try that. Just take a minute and pause the video and go ahead and try them on your own. You will feel so good when you start to get them on your own. Meanwhile, pause the video and try that and then come back. So here we have 10 times G equals 8 times the quantity of G minus 1. And 10 times G is 10G. 8, we'll distribute that. 8 times G is 8G. 8 times negative 1 is negative 8. So let's subtract 8G from both sides. And we have 2G equals negative 8. And we'll divide both sides by 2. And G equals negative 4. Number 7. Remember, go ahead and put parentheses around these to help you remember to distribute when you write out your problems. So 6 times the quantity of Z plus 7 set equal to 3 times the quantity of Z minus 9. And now we distribute. And we do that on both the right and left side of the equation. 6Z plus 7 times 6 is 42. So, and that will set equal to 3Z, and 9 times 3 is 27. That's a negative 27. So let's subtract 3Z from each side. And we end up with 3Z plus 42 equals negative 27. And now we'll subtract 42 from each side. And 3Z will equal 69. And then when we divide both sides of the equation by 3, Z equals 23. And we have a quantity here in the numerator. So we'll do 2 times the quantity of 4x plus 21 equals, we have a quantity in the denominator, 5 times the quantity of x minus 3. So this will give us, when we distribute, we will have 8x plus 42 equals 5x minus 15. And we will subtract 5x from both sides. And that will give us 3x plus 42 equals negative 15. And we'll add 42 to both sides, which will give us 3x. I'm sorry, this should have been a subtraction. Let me just fix that. I put an addition there. Okay. 3x equals 57. Negative 57. Now we divide both sides by 3, and x equals negative 19. And let's see, 9, 10, 11, and 12 look like they're absolute value problems. So let's get started on those. So once absolute value is isolated on one side of the equation, our next job is to make two cases, the positive and the negative. And this problem is already solved, so we express it in set notation with the smallest number first. And that's a final answer, negative 14 and 14. So next one, we make two cases. 8m minus 8 equals 40. 8m minus 8 equals negative 40. So we'll solve the left-hand one first. First thing we'll do is add 8 to both sides of the equation. 8m equals 48. Then we'll divide both sides of the equation by 8, and m equals 6. Not done yet. Now again, we add 8 to both sides of the equation. This time we have 8m equals negative 32. We divide both sides by 8, and here m will equal negative 4. And we express our answer, m, let me just fix that a little bit. I want to put this on this side. M equals set of all numbers such that m equals negative 4 and 6. Okay, let's move on to the next problem. Excuse me. We need to isolate this absolute value term, so we will subtract 4 from both sides of the equation. That's the first thing we need to do. And then we have the absolute value of m divided by 7 equals 1. So we make two cases. The absolute value, we remove the absolute value bars, and we have m divided by 7 equals 1, and m divided by 7 equals negative 1. So now we will multiply both sides of this equation by 7. That will clear our fraction. And m equals 7. On the right-hand side equation, same strategy. We will multiply both sides of the equation by 7, and m equals negative 7. And so our answer is m is the set of all numbers such that it includes negative 7 and 7. And that is our final answer. Now, I've said this over and over. Let's hope you remember. Do not distribute over absolute value. We do not do this. Okay, so get rid of that. We do not distribute over absolute value. Let's divide that out. Whatever we do to one side of an equation or inequality, we do to the other. Now we have the absolute value of 4p plus 4 equals positive 8. A negative divided by negative is a positive. So now we make two cases. 4p plus 4 equals 8, and 4p plus 4 equals negative 8. We'll add 4 to both, subtract 4 from both sides of the equation. Four p equals 4, and divide both sides by 4, and p equals 1. Now on the right-hand equation, again, we will subtract 4 from both sides, but with a negative 8, that gives us a different result. We will have 4p equals negative 12. We will divide both sides of the equation by 4, and p will equal negative 3. And let's write our answer in set notation, negative 3, 1, and this problem is finished. The next four, number 13, 14, 15, and 16, are literal equations. So let's get started. We're solving for v. So if we have a equals v over t, and we're solving for v, what we want to do is multiply both sides by t, and our answer is v equals, and I put them in alphabetical order, a, t. It's just multiplication, so the commutative property allows us to put them in alphabetical order like that. So here we're solving for m, and because we're solving for m, I think the first thing I want to do, even before I distribute, is multiply by 4. So I'm going to multiply both sides of the equation by 4. There's a couple ways to handle this, but I'll do it this way. So on the left side of the equation, I have negative 32, because a positive times a negative is a negative, equals m minus n, because I cleared the fraction when I multiplied by 4. So therefore, I just multiplied m and minus n by a positive 1. And now I have negative 32 equals m minus n. So remember, I'm solving for m, so that's what I need to isolate. So I'm going to add n to both sides of the equation, and that will give me n minus 32 equals m. You could write it negative 32 plus n, either way, but that's our final answer. Here we're solving a squared plus b squared equals c squared. I hope you recognize that formula. If you don't, you will become reacquainted with it very soon. It's the Pythagorean theorem. So, couple of ways to go about this. I think the first thing I will do, I'm solving for b, so I'm going to subtract a squared from both sides, which will give me b squared equals c squared minus a squared. Now, in order to isolate b from that exponent of 2, we take the square root. We've only done this a few times. I take the square root, whatever I do to one side, I do to the other, but that allows me to isolate b. So now I have b equals the square root of c squared minus a squared. That's a final answer. Now we're solving s equals 2 pi r times the quantity of h plus r for h. So the first thing I would do with this is divide both sides of this equation by 2 pi r. So now on the left side I have capital S divided by 2 pi r equals h plus r. Now what are we solving for? H. So we have to eliminate r. Whatever we do to one side of the equation, we do to the other. So h is now solved, and on the left side we have s divided by 2 pi r minus r. And that is our solution. Let me rewrite it over here. S in the numerator, 2 pi r in the denominator, minus r. And that's the complete solution. So now we've got a few word problems, and then we're done. So, first word problem, the larger of two numbers the larger of two numbers is 2 more than 5 times the smaller number. If the sum of the two numbers is 80, find both numbers. Okay, so we need to make an X box first. We'll let X equal the smaller number. And we'll let's see, 2 more than 5 times the smaller number. Okay, so we will let 4x minus, 5x plus 2 equal the larger. And then the sum of those two numbers is 80. So on the left side of the equation, box in my X box, on the left side of my equation, I have x plus 5x plus 2 equals 80. Combine like terms, 1x plus 5x is 6x plus 2 equals 80. Subtract 2 from both sides. 6x equals 78. Divide both sides by 6. And x equals 13. That means our two numbers are, well, let's see. Number 13, we're going to substitute. And that equals 67. So our two numbers are 13 and 67. Remember, just substitute whatever you find for x, substitute it in the other formula. Okay, now we're going to find 3 consecutive odd integers. Okay, so we're going to do this x plus 2, x plus 4. The sum of the smallest and the middle is 27 less than 3 times the largest. Let's define our X box first. I'll change the color here. I'm going to erase some of this so that we have a little more room. Okay, and change the color. So we're going to let X equal the first consecutive number. Then we'll let x plus 2, because they're odd integers. So 1, 3, 5, 7, 9. We skip 2 numbers. So let x plus 2 equal the second consecutive integer. And then we'll let x plus 4 equal the third. And there's our X box. Now let's set up our problem. So it says the sum of the smallest and the middle is 27 less than 3 times the largest. So the smallest is x. The middle is x plus 2 is 27 less than 3 times the largest. Well, 3 times the largest is 3 times x plus 4, but then it says 27 less. So there's our problem right there. I think once you've set it up, it gets a little easier. So let's combine like terms. I have 2x plus 2 equals, now we distribute on this side, 3x plus 12 minus 27. Now we can combine like terms over here. So we have 2x plus 2 equals 3x minus 15. 12 minus 27 is negative 15. So let's subtract 2x from each side. 2 equals x minus 15. Let's add 15 to both sides. And going to go over here. So we've got 17 equals x, or x equals 17, which is how I usually like to write it. Now, what does that mean? We need those three numbers. So the first number is 17, the next number is 19, and the next number is 21. Three consecutive odd numbers, and they equal the smallest and the middle number is 27 less than 3 times 21. If you did the substitutions, you would come out with these three numbers, and this equation would be correct. So let's look at number 19. The length of a flat screen TV is 5 inches less than 3 times its width. If the perimeter of the TV is 180 inches, find the dimensions. So we have length and width. So let x equal the width. And so it's the length is 5 inches less than 3 times. So let 3x minus 5 equal the length. And we just use our perimeter formula. So 2 times the width, which is x, plus 2 times the length, which is 3x minus 5, equals 150. So 2x plus, and we'll distribute, 2 times 3, 6x, 2 times negative 5 minus 10 equals 150. We can combine 2x and 6x, 8x minus 10 equals 150, and then we'll add 10 to both sides. 8x equals 160, and if we divide everything by 8, x equals 20. So the width, 20 inches wide, and let's do a substitution here. 3 times 20 minus 5 equals 55. So 55 inches is the length. And our last problem, Olivia and Camille went clothes shopping. Camille spent $19.40 less than twice what Olivia spent. In total, they spent $272.35. Find the amount that each girl spent. So Olivia spent, let's see, Camille spent less than twice. Looks like Camille spent more. So I'm going to make Olivia spending, let me write that a little neater. I'm going to let x equal Olivia's spending. Now, $19.40 less than twice what Camellia spent. So I'm going to let 2x minus $19.40, and that will be Camille's spending. And that's our X box. And let's set up our problem. Both of them together equal $272.35. We simply need to add these. X plus 2x minus $19.40 equals $272.35. So we combine 3x minus 1940 equals $272.35. Let's add $19.40 to both sides. Now 3x equals $291.75. We'll divide both sides by 3, and x equals, it looks like $97.25. So that's Olivia. So Olivia spent $97.25. Now we have to substitute to get Camille's spending. So 2 times 97.25 minus $19.40. If you did that calculation out, Camille will have spent $175.10. So Camille spent $175.10. And that's our final answer. I hope this was a good review for you. Please go back and answer our exit ticket question about steps to solving a word problem, how we define our variables, we set it up, we solve. And think about which is the most difficult for you. And when you do that, practice a few on your own. And I know that if you do that, you'll be great.